Exactly.
Okie dokie. So this is our second talk on our project crowdsourcing for geointelligence, which is just a continuation of research I did at MIT Lincoln Laboratory. So what we have done since we gave our last talk on crowdsourcing, we have set up the shop on Amazon's cloud, which includes like setting up a server with the SQL database and an HTTP server. We coded all of the websites that collected the data for our experiment, which our experiment was really, we showed people an image of an aerial photograph, and we asked them to place markers over the houses so we can calculate where each user put this pin and how many users put pins where. We'll see a little bit more of that later. As we did an analysis, so we collected a data set of around 30,000 points. So a pretty big data set. So we'll do a quick demo really quickly. So exactly what everybody on the crowd saw. Here we go. Got a putty error. So this is my session that I'm connecting to on Amazon. This is the Amazon EC2 cloud instance. So this is the hit just got created, and we'll go here. So this is what a user would see when they came to Amazon Mechanical Turk. They would see this interface here, and they would ask them whether or not they wanted to accept the hit or skip it, or they get a preview of it. They can't do anything while they're previewing it. They can only do it when they go on and accept it. So once we accept our hit, we can look at this. Well, oh, this crap, there's no buildings in here. So you just submit this. And that's very valid. We want to see how well people can do this. Some people might go through, this is a good control tile, because some people might go through and just, click on things and pay me my penny. So, we'll reload here to, okay, so here's something with the building on it. This one's a little more complex because we have this big building, so do they tag it twice, or do they tag it once, or what's the deal here? So, we also have buildings here, 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 whatever. Hit submit, we get a survey, dumps it into a database, and then we get to analyze it. We collect data such as time zones, where the time zones they submitted from the browser clocks. We got a lot of info from like India and Central Europe and Egypt and all over the United States, all over everywhere. So I guess here's some of the results we got back. Go for it.
This is one of our images where we have just a couple buildings that are cut off, and we can see that people put things here and here, here, here. We might not necessarily have buildings, but we have multiple points at each of those spots.
These smaller ones right here indicate one. So the ones with the bigger centers indicate multiple points. So there's a pretty high probability that there's a building here. Unless those users are just full of crap, which could very well be, because most of the Amazon Mechanical Turk, the studies have shown that the data you get back from Amazon Mechanical Turk, about a third of it to half of it is just crap. You just have to throw out. It's just terrible. So, we have to do some kind of analysis on the users and analysis on the images, but this is just, we completed this like this week. So, these are what kind of, here's another image.
This one much more closely lines up to the buildings. We think maybe did something wrong where multiple users put an offset of this one building, but over here all of these line up fairly well for every building, including that one. This is a building that's cut off, and we got an image here at the corner. You'll see more on that later. This is the image that's directly above that previous one. So this is the other half of that cut off building. You can see that some people labeled it on this side, it's right.
Yeah, so if we look at the...
So if you look at it side by side, flipped on the side there. So that was the building I was talking about earlier, and that was the first dot, and this is the offset one to the side.
So it kind of makes sense, I guess, if you look at the two images. This image, the building's more like the bigger chunk of the building is on the left-hand side of the screen. On this image, the bigger chunk of the building is kind of on the right-hand side of the screen. There's like a fence right here that, I don't know if you can see it too much, but there's like a fence right here. So like people might have just selected this as being one giant building. So, you know, there's noise in the distribution, which there's always going to be noise. So then I guess our next steps are the analysis of this huge data set. So we're going to look at clustering algorithms. We got to look at, you know, what kind of metrics we can use to grade each individual user. We got to look at, you know, some kind of sampling statistics so that when we tile this big image together, you know, we can see where all the houses are in this enormous image. So, you know, fairly straightforward, fairly simple. I guess the thing to take away from this is how simple it was to use Amazon Mechanical Turk, how fast we collected the data. We ran into some issues with SQL commands and diffing arrays and complex, you know, it took way too much time for us to diff an array, so we ended up using a SQL command, but you know, it took us about, what, 6-7 hours to collect 2,000 results. So and you know, that's we started with 5,000. We lost the first like 2,000 in a couple hours, and then the server started crashing because of load issues and diffing these huge arrays. And then once we fixed everything, then the last, you know, 2,000 went, 2,500 went in 6-7 hours. So I don't know. That's Amazon Mechanical Turk exists, and it's awesome to truth these huge data sets. So. Any questions? Yeah.
How much did all those results cost over the 6 or 7 hours?
It was a penny for each experiment. We ran 4,550 experiments, so $45.50. There's a potential. We collected 20 data points at max, 20 data points for each tile. So there was a potential for 900,000, I think. Unique data points. So that comes down, that's like a 1/20 of a cent for each marker. So, pretty good deal. Yes?
What did you use to do heat map generation?
Heatmap.py.
Okay, cool.
It's just, here, actually.
That's actually what I used for that Yelp dataset visualizer too.
Yep, so yeah, just heatmap.py.
I thought I recognized that.
Yeah, I don't know, we found it today, so. It worked out. Anything else? Yes.
I know you ran your backend for this on an EC2 instance. What kind of, and you said it was crashing due to load instances. What kind of like low level and just like bandwidth do these sort of Mechanical Turk queries?
Well, okay, so here's the thing. The server instance that we're running is called a micro instance, which means that it's a burst cycle CPU. So about 50% of the CPU cycle is at 100% max utilization, and then it cycles off for you know, a couple seconds at, you know, 25%. So in our code, we were pulling all of the images from the database that the user had done and diffing it against all of the images that are total. And for each user that just generated, after, you know, a user done 200 images or so, that's just a huge diff. And you know, you get 10 users on there and they're diffing these, you know, arrays, which are, I don't know what the complexity is, but I'm pretty sure it's either, if it's not exponential, it's really big polynomial. So it was just, we couldn't even like connect with PuTTY with SSH, just the server was just way too maxed out and just timing out everything. And so, and I don't know anything about SQL. I don't know anything about like database interface or whatever, but we found a SQL command that allowed us to just, a not in command, basically, the not in SQL command, I don't even know, so it ended up working. Yeah, but the micro instance was definitely, you know, if we were to do it again, the micro instance is free. So we get as being an Amazon EC2, we get a year, when you sign up you get a year of free EC2 usage on the micro instance. But the smaller instances, the medium instances cost, I think it's less than 10 cents an hour. So it's pretty cheap.
And so yours was mostly your own processing on the stuff rather than the like Mechanical Turk itself generating load.
Yes. Yeah, it's the Mechanical Turk interface that I showed earlier with the demo. It's just an iframe that loads the source, you know, the page from my site.
So just giving a web page.
Yeah, pretty much. There's a couple data structures you have to have, but yeah.
So you're kind of marrying two Amazon technologies then, Mechanical Turk and then your micro instance to do the server.
Yes, and Amazon is very user-friendly when it comes towards interfacing multiple parts of their technology. They have really great documentation, like exceptional documentation. They have multiple ways to interface. They have a command line tool, which is what I used, which just right from the server I can just call like a bash script that loads it. They have an API that you can develop to have complete control over it, and then they have a web interface. You can even not even use your EC2. You can just do it all on MTurk and web interface and get all the results back that way. But you have more control